So we are going to do this, and tomorrow I'm going to do the lab. You're going to remind me to do the lab tomorrow, hopefully. Okay, so but we finished this problem, correct?
Yes.
Perfect. I don't want to do it again. So I already did these problems before class, and these seem pretty good. So yeah, hopefully I don't mess up because I actually did them right before class. Um, First off, we need to start drawing. We need to figure out what are we doing here. We're going to draw this picture here. We need a triangle there. This is super easy. Isn't it just at 5 and at 5 and then 0? So like there's my triangle in a way. Are y'all like in agreement with me?
Yes.
It's an easy triangle, right? What I need is to not just find the area of the triangle. That'd be easy, right? No, but we have this, I guess, what you would call a variable density. A variable density. And that's the problem. We need to integrate this thing over that region. Yeah. So how do we do that? Of course, double integral of this thing, and then dy dx. But the problem is that I need to know what am I going to put for my limits. Given that we have a region, right? In a way, if you remember, this is a little r down here. R for region. So what specifics can I put here?
So my first thought is, since we have 2 points, x equals 5 and x equals 0, that would be one of our points from 0 to 5.
0 to 5 for x.
The same thing for y, since we have a 0 and a 5 in the points for y.
0 to 5 for y. Now the problem with that, and it's very close, the problem with that is that you just made a rectangle. You said 0 to 5, 0 to 5, without any change in there, you know what I mean?
Right.
I mean, it is so super close, though.
So we have to multiply that by 1.5 to get the triangle instead of the rectangle.
Not quite, because this variable density, it's going to be like super dense over here and very light over here, and it's going to throw everything off. You can't just divide by 2.
Okay, so
Yes. Yeah, modify this stuff here. I'm going to say that the 0 to 5 for x is awesome, because that's the last thing we're going to do. We always should end with numbers in the end, because if we don't have numbers right here, then we're not going to get a number answer. And then they want a number answer. Okay, so go ahead. There you go. This is a line. So how can I make this into a line equation? It's going to be y equals mx plus b essentially, right? But what would be my slope? What would be my y-intercept? There you go. Very good. Negative x plus 5. Negative 1 technically, because it's a going down. And the reason why it's 1 is because we start at 5 and we end at 5. And so it's like a 1-to-1 ratio in a way. Very good. That is my line. So where do I put it up here? You did the first half. Now it's for somebody else. Yes, it's going to be your y. It's going to go up here or down here. So you take a pick here. Top or bottom? Top. And it is the top, because it is on the top of that region, isn't it? What would then be for y value? We're looking for y values here. What would be on the bottom of this region? 0 indeed. And there you go. And so we are actually saying top and bottom functions. I put bottoms. Top and bottom functions here. Exactly. Is that okay? Good? Okay, cool. There's coffee today, just in case you want some. Okay, that's cool. I had some coffee yesterday while we were sitting in traffic for an hour, and I went nuts. It was really good coffee. I loved it. Moving on. So we need to integrate, and I basically need to do the y part first, and just don't worry about all this stuff yet. We just want to worry about the actual integration. So what would I integrate, like in terms of y? What would I get here for this x squared? I'm going to integrate. Oh, me too. Yes, x squared y. Very good. I'm going to put them in x, y, and z order. But yeah, you're exactly right. You're exactly right. And then in terms of y for this guy? Very good. Y cubed over 3, 1/3. I love it. That's great. From the 0 to negative x plus 5 dx. Exactly. No problems there. And now we have to plug it in. So this is where we have to, do a little bit of math here. So x squared times negative x plus 5, negative x plus 5 cubed all over 3. And then that's it, actually. But why? Why is that okay, Chad? I mean, didn't we also have to plug in the bottom number as well? Exactly. Yes. Indeed, you have that right. That's exactly right. Now, we got to integrate again, right? What would be the best strategy for integrating that? Calculator, exactly. But that would be on the final. Until then, we still have to do it manually. Yes. Yes, simplify right here for sure. That's an easy one. So negative x cubed, 5x squared, 1/3 in the front, and so I'm going to leave it alone. Because simplify literally means to simplify it. Would you want to actually expand that cube? Is that simple anymore? I mean, we love polynomials, but I think I can probably integrate that. If you want to do u sub, that's awesome. I'm gonna do a Chad sub, but indeed, the u sub is the correct answer. I'm just I'm lazy. So integrating in terms of x. Oh, okay. Negative x 4 over 4. Very good. And this guy? Cool, cool. I'm going to keep the 1/3 in the front. When I integrate this, the du, I guess you can say, would be a -1. And so all I'm doing is changing its sign, SIGN sign, to a negative. And then that's a 3, so it's going to get a, so I'm going to say times. It's going to get a -1/4 in the front, essentially. And now it's to the 4th power. So let's pause on that. Yeah, it's u sub. It is. And I just skipped it. I think we'll be okay. I just did this before class. It should be fine. But do you understand what I'm doing there, though? I'm saying, what's my du from the inside? -1. So really, you're just switching your sign on the outside. Everything else is the same. If there was like a 2 in the front, you just say, oh, well then divide by 2 or multiply by 2 or whatever. Is it the case? Just make it easy. Now, what I'm going to do is I'm going to type this all in to Desmos so that we can get answers very fast. That's going to be -1/12, essentially. I feel like I did something wrong, but I don't know. No, this is good. So plugging in the 5, I'm just going to go start writing down here. We get 625 over 12 minus, and I plug in a 0. I get the same thing but negative. 2 negatives make a positive. 625 over 6. I'm going to flash the answer. See? 625 over 6. With all my awesome math that I had done earlier. I even drew a picture. So yeah, there we go. So I would definitely recommend Desmos Scientific to help us at some point. I mean, because like, come on, do we really want to plug it in? Exactly. So a little bit of help is always nice. That's funny. Or a slide rule. That's always fun. Yeah. Good. Okay, I'm gonna keep scrolling then. Fun times up ahead. See what they're wanting to do here is change the order of integration. And so this is I know, like, why? And I'm going to say X because it's literally the opposite. Um, we want to make this not more difficult, but we're wanting to see if there's a possibility there. All right. Notice one other cool thing about this, though. Do you see like a box right here saying, "What's the answer?" Ha 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 ha! We don't actually have to do any math. Well, at least any calculus. So first off, which of these regions would it be? I know you can just graph it, but we're not doing homework yet. We're imagining it's an exam. Notice that it's X. And so these guys here are all X's. I'm saying X equals square root of Y. X equals Y over 9. Right? None of that is cool at all. Nobody graphs X equals. What would this actually be? Y equals... Beautiful. And this guy? 9x. Very good. These I know. These I've seen. No problem here. We got a parabola dude. We got a line going up. And you can see where they're kind of like colliding here. It's one of these dudes. Yay! But I think we can at least get one of them. Or we can 50-50 them. Right. It's. But what about this guy? Oh, you see it. I see what you're saying. Look, I didn't. Okay, so I was just looking at the picture, but you're right. Negatives. Look at those guys. I did not see that. You are 100% correct. So when I was looking at it, I chose this one because of the curve of it. Notice that it curves and then it kind of goes, like a parabola. But yeah, those negatives are completely wrong. So good. Good eye for that. Okay, cool. Okay, well, now that we got the picture, now we need to rearrange it. And so notice it went from dx dy to dy dx. Now, is that important? Is that helpful to us right now? No. Is that going to be helpful later? Oh, yeah. Oh, yeah, because we're going to get triple integral, blah, 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 and you're like, I don't know where to start. And we have to, like, flip things around to make it work. So this is just a skill. We're just developing skills here. Again, we know that y equals x squared, y equals 9x, and I want to start doing integration stuff of 1 dy dx. So again, these are y's right here. I'm saying this is y equals. Y equals. I want to also remind you that what's on the top is on the top, and what's on the bottom is on the bottom. Oh my gosh. So which of these two guys would go on the top? Be careful. 9x is on the top. Very good. And x squared would be on the bottom. And the reason why is because if you look at that line, the line's on top of the parabola. I mean, I wish I could just zoom in here. Let me try to zoom in. But the line is here, and then the parabola is on the bottom. It's very easy for you to think x squared is bigger, right? So it needs to go up top. Oh man, and it's true for like bigger numbers. But here we're talking like right next to the origin. And so higher degrees are actually smaller. It's very strange. Okay, so these are x equals. I need x equals to be stuck in here now. Like, I guess those are my answers, by the way. So looking at my picture, I need x values. Give me some x values. 0 to 9. It's like looking right at the picture. You're done, right? 0 to 9, right there. So it's helpful that we had a picture. How would I have figured that out beforehand in a way? Well, a few ways. You could set these equal to one another, right? So you got x squared is equal to 9x. Obviously, you can factor an x out on both sides. What happened there was, okay, I have to be very careful. I got in so much trouble doing this. You cannot cancel x on both sides. But what it means is that x equals 0. I just want to make sure you understand that it's not okay, but it does mean something. There you go. So x equals 0, x equals 9. There you go.
Thank you, Chad.
What?
I'm making a joke.
Okay.
It's funny enough that I did have issues with that in section 14.7 or something like that.
It happens to me all the time, man. Like, it doesn't anymore because it's so embedded in my brain that I messed up for so many years. Somehow I still pass graduate school, so you can do it too. Yes. Yes, you have right here y equals 0. You plug that in, you get a 0. You have here a y equals 81. So then you say square root of 81 is a 9. Very good. I like that. That's way better. Yes. Cool. So those are the answers. And like, I guess I could show my answers, but I didn't really do as much because there's not much to talk about. So cool. How about y'all do this one? This is a you do. Oh yeah. And in the meantime, I'm gonna get a little coffee. I'll start freaking out. I got the coffee from Sefco. $2.15, by the way. So good. It was in like the middle of the afternoon too. It was just such a beautiful brew.
So, Chad, I do have one question before I get started. We still treat this as the same, even though this one has an x plus y instead of 1, like we had in the question before, would still be treated as the same process?
Yes, because you can see x plus y, x plus y. They haven't changed that at all.
Okay.
Yeah, we're not actually integrating. And so it doesn't really matter. We're just, yeah, it's literally the same process because, again, we're not really integrating yet. Good eye for that, though. I also have to admit that I did not do this one before class. I looked at it and said, we could probably do that. So I might be getting it wrong. We'll see. I think I drew the picture for it, though. Aren't y'all excited to be back after a whole week of not seeing me?
I am, Chad.
Thank you. Thank you. I'm happy to be back too. Five, four, three, two, one. So these are x's. I got x is equal to y, or e to the y, and then I got x is equal to 1.
That's how. That's what I was getting.
Oh.
I was seeing that as x e y, just y times e.
Yeah. Yeah, right. Yeah. Yay. Yo. No, power. If I wanted to start switching things around, y equals what?
Ln x.
Very good. ln x. But Chad, you need to do absolute value signs. No, I'm sorry. I'm just joking around there. Wasn't that a big thing? Was it Cal 1 that was the thing?
I believe so. There's also one question
Here.
where it's like, unless you had
So I need to convert this over to a y equals. You can't. You can't. I was just joking. You can't. But we do have from down over here, those are y's, right? We have a y equals 2 and a y equals 0. So A, B, C, or D? You like C? You like C? I'm questioning.
So matches the ln x as well, since it's going from like a curve upwards.
I think I got A with my answer, but if you say C, here, let's flash the answer. They say A.
Yeah.
Urgh.
On the y-axis, not
Bro, you went from a 100 down to a 99.999999. That's what it is yeah, it's the recovery. So I'm thinking it's this because I want to start graphing it, right? First off, we got to graph the ln x. That's the main thing. Like you were saying, the ln does this swoopy whoop kind of thing, right? So that disqualifies this one and this one for sure. And we're down to these guys. Let's graph the rest. I got x equals 1, which that's a vertical line, right? I got y equals 0, which is a horizontal line. And I got y equals 2, which is somewhere up here. And so, like, in a way, I'm thinking these 3, 4 lines or so are defining where it should be. And one of them's redundant. Do you see how I'm kind of like filling in where it should go? By drawing all the pictures. So far, so good with that? And now we just got to put them all back. Remember that this bottom here we're saying is a y equals, and up here is a y equals. I want it bigger. I want it bigger. Let me get it bigger. Okay, there we go. So we have a y equals on top and a y equals on the bottom. Top and bottom. What would go on the top according to my picture? 2. And what would go on the bottom? I love that. That's correct. If you're looking at the picture, it's best to say that it's the ln x at the use red and orange. It's best to see that ln x on the bottom, and then this line is at the top. Okay. Now, couldn't 0 also technically be on the bottom? But it doesn't define it as well, right? What? It'd leave you with a box. Very good. Exactly. Which it's kind of meaningless. So sometimes they give you extra information that we don't need. Like we just don't need that one. But everything else is fine. All right. So for the x's, again, what's and I say top and bottom. I want to keep that idea, but top really it means like the right side, and bottom means the left side in X land. So what would be on the right side? Yeah, it's going to be whatever that thing is. Where's on the left side? That was easier. 1 for sure, yep. So right, how do we find that last bit? Is that we need to find out where they intersect. We have y equals this and we have y equals that. Let's kind of mush these together, and it's x equals like e squared or something. Is that what it is? Flash the answer. E squared, yeah. You got it. Cool. Yeah, e squared. Cool. What is e squared without using that awesome calculator right there? Thanks. Yeah. Why ask these terrible things? Oh, I was off. I was thinking like 5. I was wrong. Correct. Very good. Very good. Y'all are just so smart. And I ask stupid questions once in a while. Any questions? Are we good? I'm going to move on, okay? Scrolly. All right, the wedge. I got this one wrong before class, and then I said, we'll figure it out later. But then I went and did it again. I got it right. So, I think first what we need to do is draw a picture of what we're looking at. And so this is definitely a 3D thing. This is cylinder, and I don't have a perfect idea of what's going on here, but we have a z equals with this thing. I mean, to me, I'm just looking at this thing, and it looks more not like cylinder, but more like a tunnel. It's like upside down, and again, x doesn't matter, so it's kind of like this. It's like an upside down parabola. It's like a tunnel, I'd say, right? So that's the initial picture. I'm gonna get rid of my whatever this is in the middle. There we go. So I've got this tunnel that I'm like, okay. It also says first octant, which means it's stopping at 0. Okay. So this is kind of like our shape, right? It looks kind of like this from the side, but if we were to look at it from the other side, it would almost look like a rectangle. But we know that it's like a cave tunnel thing, right? Is that cool so far? You good with a picture of what we're looking at? Okay, cool. But they said first octant. And that's not just the bottom plane. That means all of this up here too. And so it's like I'm cutting it in half. I'm cutting it in half. And so I'm going to try to cut this thing in half now. I'm going to revise my picture. It looks kind of like vrump. There we go. So far, are y'all seeing it? So it was a tunnel, but I cut it in half. Then I need to cut it with a plane. And then this plane right here, it doesn't have any Z's, does it? How do I graph this plane? What if I thought of it not like a plane, but a line?
Yeah, could we solve y and plug it in?
Boom. Y equals 2 minus x. And so if we were to do 2D, that would look kind of like this, right? But in 3D, again, this is my origin right here. But in 3D, it's kind of like a vertical plane thingy, right? That's slicing it. So I'm slicing it straight up and down like this. Now, exactly where they collide and all that stuff, I'm not exactly sure. But how do I graph this now, right? And that's tough. I'd have to say one of the hardest things to graph are the wedges. So we're coming down, but then at some point it just kind of stops. So there you go. That's terrible. It's like a cheese wedge. Okay. Great, Chad. Thanks. Cheese wedge. Okay. I don't think that's helping much. Are y'all seeing the visual of how it's a complicated shape? Okay, good. Very complicated, and that's why we need double integrals to do it. Thankfully, it doesn't have a variable density, and so that's kind of nice. In a way here, I actually want to do a triple integral of 1 dv, because this is find the volume. That's what I'm going to do to find the volume is triple integral, right? But when I do that, and again, this is dz, dy, dx, we already talked about this. It immediately translates into a double integral of z dy dx. Like, what's the integral of 1? Z, I guess. Just a variable, right? Do we have a z? We do! So, aha! I could just toss that dude right in. Dy dx. You see that I'm trying to make the theory work for you, right? In theory, we look for a volume. Immediately, you should continue to think triple integral. And from there, it's like, okay, well, what's the density? They didn't say it, so it's a uniform density. 1. Do my first integral is always just the variable, and then we could toss that in because we have it. It's like we're actually evaluating from 0 to z equals blah, blah, blah. Cool? But now we actually have to get to the hard part, because like the x's and y's are what was hard. What then would go on the bottom and the top of my y's? Like again, these are y equals. So what would I be putting there? Okay, we're getting close. Again, these are going to be variables probably.
I don't know if this is correct, but my first guess is since we had the plane, aka the line, we have it as y equals x minus or 2 minus x.
Yeah, we
That's
should
gonna
use
be
that.
one of them. And since we know it's in the first octant, we know it's also going to have a 0 as well. So I'm thinking 0 to 2 minus x.
100% true. Everything you said was perfect. So I'm going to repeat it for the folks at home. Basically, we're looking here at our line / plane thing. And then we also have first octant, which is kind of like an automatic 0 for our bottoms. And that's probably the case. I won't always say it, but yeah, basically always. So what's on the top is this line. What's on the bottom is going to be 0. Very good. Very good. And so then, therefore, left and right, or just x bottom top, what would I put for my x's? What's the bottom x? What's the smallest x? 0. Yeah, we can agree with that. So where are they touching? That's the question here. Where are the where's the plane touching this line? Say it. 2, because it's y equals 0, y equals this thing, and then we're setting them equal to another, and x equals 2. 2, exactly. Very good. Go away. Go away. Nope. Okay, yeah, there we go. So let me rewrite it. I'm not going to do it yet, but I'm just rewriting it. Also, this green is eating my eyes, so I'm going to change my colors here in a second. I mean, I like green. It's too soothing. We need red. Oh, I ran out of room. No. Okay, well. Yeah. I could say that some other professors out there, they would say, "Oh, you've done this before. Let's continue moving on." You laugh, but it's true. So, I would like to do it nonetheless, because I want to know if I'm doing it right. So I'm integrating in terms of y. What should I get there? Beautiful. And then,
You should get just y cubed.
beautiful. It's perfect because the 3's are going to cancel. Very good. From 0 to this mess, 0 cancels everything out, so that's nice. But we're still left with some junk. Okay, the red's too much, man. I can't do the red. Let's go back to blue. When I integrate this, I actually would rather distribute first, personally. Oh, I'm already integrating. That's right. 24x minus 12x squared all over 2. We have to divide by 2 there, don't we? And then here, yes, u sub, etc., blah, blah, blah. But couldn't I just say that the 4th power du is a negative, so I change it to a positive? 4th in the front, 4th power. Is that an okay way to do it? In Calculus 3? Okay, good.
I did it the long way. That's what I got. So yeah.
Okay, cool. Calculator. I'm looking at this thing like, what do we do now? Yeah, we do calculator, duh. That's a 6x squared, technically. $24, and then minus, remember we still have to plug in the 0. It doesn't always zero out. Oh, see, there you go, 4, so 20, and that is the answer. So just plug it in, of course. Oh yeah, I can sit here all day. I'm drinking coffee now. Depends. After I got back from sitting in traffic for an hour and drinking coffee, I started putting music on the headphones, blasting it. I asked my wife, "Can I go next door to program for like an hour without the kids?" She's like, "Yeah, I guess that's fine." And I did. And I got a lot of stuff done. I did. I went from here to here was the second integral. Yes. Yeah, because I didn't ask. I just did it. But I took the happy times away from you. That's the thing, right? I should have y'all do those things. And look, go ahead. Yes. Right here, 12 times 2 is 24. But it doesn't have an X.
Oh, okay. I see.
Cool. Oh, and I can flash the answers and verify with you, see? And I did it already. Yeah. And that was wrong. I did it wrong. I just mistyped something, I think. But anyways. Cool. I'm also learning, look, I got like big integrals, tiny fitted on the page. So I need to chill out there a little bit. Okay, infinities, skip. So y'all are totally okay with infinities, right? Y'all have done Cal 2? Yeah. I gotta say, this was the easiest one I've ever done, though. There will be harder ones with these, but not so much in this class, I don't think. The main idea is we need to do one at a time. And notice that because it's multiplied right here, I can kind of separate them into two separate fractions. Imagine that we have this guy times this guy, right? And so then I'm saying I want to take the integral in terms of y. Well, if I do that, then this is just a variable sitting in the front. It's being multiplied. So like I only have to focus on this guy, and then I only have to focus on this guy, which is nice. They split it up perfectly for us. Did you notice something I did wrong already?
It's dx dy.
Yeah, but I don't care. So, because they're both infinities, right? So it shouldn't matter here in this case. Do you remember? Do you remember the integral of that thing right here? Do you at least remember where to look? What it would be kind of?
It looks like arctan.
Arctan. You got it. It's 1 over A. A in this case is a 4. Arctan of that variable, which is just, I think it might be A or that variable over A or something. It doesn't really matter in the end here in a second, but yeah. So A is a 4, so we just do arctan. There we go. I still have to go negative infinity to infinity with it. But what if I plug in infinity or even negative infinity to arctan? Do you remember what values we get? Let's review. Arctan does this. Well, it's close. It's basically the same thing. But what are those horizontal asymptotes? Pi over 2. Yeah. Because they go from negative 90 to positive 90. And because of that, you get a negative and a positive, but two negatives will make a positive, which makes this whole thing so much nicer. So the 1/4 is going to come to the front with this. Notice two negatives make a positive. You got a half plus a half is a whole pi. I know the 1/4 is still there. Go ahead. I did. Yeah, I mean, we have y over 4, and when you plug in an infinity there, it doesn't really matter if you divide. This guy right here? Correct. You're okay. Yeah, it's like a big variable number thingy in the front. Yeah. Hey guys, what's the integral of this x thingy? Just say the name of it. It's arctan again. This time 1/5 arctan of x over 5. Again, from negative infinity to infinity. When I plug in infinity, we get pi over 2 again. Yeah, you got it. Again, 2 halves make a whole. So remember, we're multiplying. It's pi times pi. So that's actually pi squared. And just to verify, I'm going to flash the answer. Pi squared. See? Cool. So it wasn't too bad. And like, you just have to kind of remember or go look up some of these little integrals that we don't use all the time. Well, yeah, that's not in this class. We use formulas here. I know, right? Yeah. Overall, though, is this okay? We're good? Happy times, right? Do y'all go home and say this kind of stuff to the, to your families or whatever? Say, what did I do today? Oh, let me tell you, we did, double integral with infinities and stuff, and improper integral plane.
The only person I can do that with is Scott. So.
Oh, well, he's in a different state.
Yeah.
Okay. Do you call him often though?
I would play games often.
Okay. So do you talk about math when you're playing games?
Occasionally, not all the time.
Math games. Yeah, math games. Yeah, yeah. Who has the higher score in Call of Duty? I'm I don't know. Good? Oh, yeah. You're fine. That's why we talk about Call of Duty or whatever. Is it Call of Duty? What do y'all play together?
There's Call of Duty, yeah. But the game we've been playing recently is Mario Kart.
Oh. Okay, that's good. Mario Kart's great, bro.
Oh, yeah.
I mean, I'm just... It's funny. I was expecting, like... No.
I don't think we played Call of Duty for a year, maybe 2 now.
Okay.
Yeah.
I haven't played it in many years. So... Okay, good. But that's what kids will do to you. You're like, I don't want my kids to be watching this Call of Duty stuff. So, just saying. Moving on. Still not allowed to get Grand Theft Auto anymore. Dang. So, area by double integration, it's just what we've already been doing. And this is the shortest section because I think there's only 2 questions here. We got this one and we got that one, and then we're done. So there's really not much to talk about here. There's nothing new except for the small formula, the average value thing. It's just a formula. That's all it is. Notice that its area is being divided by. So you're doing 2 integrals actually. This right here is this. So I would like to actually give you a better formula, and this one going forward is more important. I'd say it's double integral of f dA divided by double integral of 1 dA. If you want to put a 1 in there, that makes more sense, at least. So that's your average value. I can't remember because it's been a while since I set the class up, but I think that we have moments of inertia, and this is a very similar formula to those. So we'll be seeing this style of, like, do it twice eventually. Again. Cool? Okay. So that, yeah, double integral on the top, double integral bottom, but again, one has an F, one has a not F. Okay. So Are they? Yeah, they actually do want the area of this thing. We're not going to do the average thing, so I'm just going to go away from that. You good? You good, Ryan? Okay, I don't mind. I could just sit here all day. You're good now? Okay, good. So let's just do this one. I mean, I think it's kind of easy. I need to get some pictures. I got x is equal to 2y. I got x is equal to the y squared over 3. But we don't use x equals, use y equals. So what do we have here? I love that. And then this guy here, it looks like an 8 now. Sorry.
Wouldn't that be 3x to the 1/2 power?
To the 1/2 power. Yeah? Is that correct? You like that? Cool. I also have y equals 6 and y equals 0. If I were to plug these things in, like, I don't know, maybe these two right here, what would I get out of that?
Wouldn't that be x equals 3
Okay.
to the top?
Actually, yeah, if you plug in a 6 right here,
Oh wait, that'd be 12.
yeah, 12. And I'm going to verify. Yeah, if I plugged in a 6 right here, 6 squared is 36, and then I divide by 3 to get a 12 again. Yes. Okay, 12. And of course, what do you think the other x is going to be? Just take a guess.
0.
Yeah, probably. So, with these and these, which one makes the most sense? Heck, even these. You like C? I like C as well. Notice that we have right here x equals 12, y equals 6, which we have both of those. And we got the 0, 0, which this one has, this one doesn't have. I don't trust that guy.
It's also on the origin. That one has the cost has the origin.
True that, yeah.
Like you
Mm-hmm,
shift it to the right, yeah.
mm-hmm, mm-hmm. Yeah,
Not just you don't see the other side. Oh right, yeah. it should
right,
have to.
yeah.
The formulas are the same. Yeah.
Well, I think the formulas are deceptive because, see, the formulas are the same everywhere.
I'm not meaning the curves.
Oh, yeah, yeah. You're right, yeah, definitely, definitely. And yeah, so I want to say like this one looks pretty good, but then that 2 is not making sense because we need a 6. So, all right. So yeah, that one's no good. This one's awesome. So find the area. We can do it straight up the way this is right here, and that's fine. Or I'm gonna write a big or. We could do it this other way, dy dx. If so, looking at what's top and bottom, again, this one's easy for the x is 0 to 12. But what would be on the top for my y's? Out of these two right here, which on the top?
Doesn't top stay on top?
Top stays on the top. So what would that be?
1/2 x.
Oh, you mean like because it was from the top here?
Yeah.
I wouldn't guarantee it.
Okay.
I wouldn't guarantee it because what sometimes it means top and bottom, sometimes it means left and right. So if you get a negative, it could be something opposite. I would just be super careful, but it's true in this case.
So this deals like a lot with like the dishwasher method, where it's like top, bottom, and left and right. Like
Actually, I think it's false in this case. If you look at my picture here. What's on the top is that square root.
right.
Oh, so it actually flipped on you. There's your proof case that it's not always that way.
Yeah, that's what I mean. Like it takes like the method like dishwasher, where it's like top, bottom, or left to right.
Mm-hmm.
Yeah.
Yes. Whatever you said. But because it's a 1, it's super easy to integrate. And I'm choosing this one because I just wanted to have more practice, really. So we got square root of 3x minus 1/2 x dx, I guess. Yeah, there's not even a win bar anymore. That was it. I want to do one small thing. I don't know if you often think about this. I'm going to rewrite that first one just so that it looks a little funny, but it also makes it so much easier to integrate. You see what I did there, right? Oh, so we're going to integrate now. Yeah. So if I'm integrating this guy, add 1 to the power, divide by the new power, what would I actually get there?
We get
2 over 3. Very good. Then? Very good, very good. I think I interrupted you, I'm sorry, but you're right, exactly. And keep the square root 3, of course.
Oh, I see. You pulled out the square root 3. That's where I was getting confused at.
Right. Right. I was just integrating that x to the 1/2. But I pulled it out because it would have been like weird. Some of y'all might say, "Oh, use substitution," and like I just don't like doing that. Apparently, nothing personal against it. It's just not really on my agenda mostly.
Right. Well, it makes perfect sense. It's a constant. You put it out to the front, and then
Yeah.
you just
Exactly.
click in my head for a minute.
That's good.
That other half is just 1 over 4 x squared.
Yes. Yes, that would be a 4 in the end. Very good.
Well, the way you read it, looks like power is divided by 2.
Yeah, I was trying to say like x turns into this dude, and then keep the 1/2.
I kind of figured when you
I'm not perfect either. And at this point, of course, plug it in to a calculator if possible. Are y'all okay switching those variables around? We're okay with that? I can't plug this in anymore. It's not the same. Grrr. Right, do you see it? It's got a square root 3 over here. That makes me so angry. I can't just blah get the answer. Okay, you know what? I can. This is just not right. This is not right. Everything I'm doing, just stop. Just don't do it, Chad. Plugging in a 12. Ew. You can't just plug in an X there, bro. How gross. You're actually like typing a 12? Okay, sorry, but need a little bit more room. Oh, the zeros are going to cancel. Do we get something look at that. Well, because the square root, and it makes me nervous. True. Well, you were right. You're right. See how I did it the other way? I think I did dx first. So I just did this, and it was pretty easy. It was actually a little easier, I think. So, either way though. Cool. Good with that. We got 2 minutes. We got plenty of time for this one. No way, not at all. So we'll do that average for. Oh no, we're not, because what are we doing next time? Thank you. All right, we're done for the day. Thanks for hanging out, guys. Bye bye.